All right, now we're going to talk about measures of positions and outliers. The very first thing I want to talk about is z-score, and let me stress to you why this is important. Let's say that you're taking the SATs and the ACT when you're in high school, like high school students are taking them. And so they're taking the SATs and the ACTs. And so your kid or brother or sister, whoever you want to imagine, comes and says, oh, I made an 1100 on my SATs, and I made a 52 on my ACTs. Well, which one did they do better on? Okay? It's really hard to tell because they're on different scales, right? I think your SATs go to like 1600, or at least it did when I was in school. And then the ACTs go up to like 75 or something like that. So it's kind of hard to tell what test you did better on, what test you want to submit to your college. So what you can do is you can transfer both of these scores to a z-score, and it tells you the distance from the mean. It standardizes the score. The formula to do that is you take your score, your x value, and you subtract the mean, and then you divide it by the standard deviation. Now, hopefully now you can tell the difference between these two. This one is in regards to population. This is when I'm using mu for average, okay? And I'm using the symbol, I think it's small sigma. I could be wrong. I don't memorize Greek symbols, but that's in regards to population. And of course, this one is in regards to a sample. Okay, so let's look at this this problem. We're talking about babies, okay? You can deliver, I think, after 34 weeks, if I'm not mistaken. I had a daughter, but she made it all the way to 40 weeks, so I really don't know. But I think after 34 weeks, it's safe to deliver. So they say that if a baby delivers between 32 to 35 weeks, the average weight of the baby is 2,700 grams with a standard deviation of 900 grams. Okay? If the baby makes it all the way to 40 weeks, the average weight for a baby who makes it to 40 weeks is 3,300 grams with a standard deviation of 530 grams. So two babies were born. One was 33 weeks along, and that baby weighed 3,125 grams. A 40-week baby was born, and that baby weighed 3,725 grams. So which baby weighs more in relative to their gestation period? Okay? So, right now, you're like, well, the 40-week baby weighs more. True, the 40-week baby does weigh more than the 33-week baby. We're talking about in relative to their gestation period. So the thing you want to do is you want to standardize these weights by making them into z-scores, okay? So what I'm going to do is I'm going to take the 3125 and I'm going to subtract the mean in that gestation period, and the mean is 2,700. Then I'm going to divide that value by 900, which is the standard deviation. So the 33-week baby z-score is 0.47. And then I'm going to do the same thing with a 40-week baby. I'm going to subtract its average and then divide by its standard deviation. And I get 0.8. So the 40-week baby weighs more because its z-score is larger. Okay? Easy peasy. Okay, now I want you to try this problem. Hope maybe this will make a little bit more sense. Like, I'm 5'6", and so I think I'm pretty tall for a woman. And then my husband is like 5'7", so I think he's pretty short for a guy. So even though he's taller than me, he's shorter than the average male, and I'm taller than the average female. So, I'm pretty much average, but I'm just saying. So do you understand? So even though he's taller than me, so I want you to look at this data. A man who's between 20 and 29 years old usually average has the height of 69.4 inches with a standard deviation of 3.1 inches. A 20 to 29-year-old woman has the average of 64.1 inches with a standard deviation of 3.8 inches. So I have a 75-inch man and a 70-inch woman, and I want you to tell me who's relatively taller. So go ahead and pause it, work it out, and see if you come up with the answer that I do. Alright, here we go. So I took 75 inches, subtracted the 69.4, divided by 3.1, and got the z-score of 1.81. I took the woman, 70 inches, subtracted her 64.1 average for women, and divided by 3.8, and I got 1.55 as the standard deviation. So the man is relatively taller in terms of his gender. Okay, let's look at this problem. A college will only admit students within 2 standard deviations above the mean on a test. The test stats, the average test score made is 200, and the standard deviation is 26. What is the minimum score that a student can make on this test in order to get into the school? Okay, so we know for like z-score, we would have to take the score, subtract 200, divide by 26. Okay, and we want it to be greater or equal to 2. So let's go ahead and make it equal to 2. Okay, because we want it to be 2 standard deviations above the average in order to even get into this college. You can't be average. You have to be 2 standard deviations above it. So we're going to go ahead and equal to 2. So if you're over 2, that's awesome. You can get in. So we want it to be equal to 2 to get the minimum test score that we need. Okay? Then we're just going to solve for x. This is basic algebra. We're going to solve for x, which is the score, in order to see what the score has to be. So I'm going to multiply both sides by 26. So 2 times 26 is 52. So I get x minus 200 equals 52. Okay? Then they're subtracting to 200, so I'm going to add 200 to both sides. And I get x equals 252. So this person would have to make a minimum of 252 in order to get into the school. Okay, the next thing I want to talk about are percentiles. Percentiles, quartiles, that kind of thing. And what it's doing is you're just dividing data, okay? Percentiles, you're usually looking at data over 100, over 100%. So for example, if they say, oh, your daughter is in the 73rd percentile for her height, okay? And moms hear that all the time when we take our babies in for checkups for their height, their weight. So if she's in the 73rd percentile for her height, what does that mean to me? That means to me if there were 100 kids and they lined them up from the shortest kid to the biggest kid, my daughter would be number 73. Does that make sense? 50 would be the average. My daughter would be number 73 if she was in the 73rd percentile. Okay? Business usually uses quartiles. And quartiles is when you break your data up into 4 pieces. Okay? So to find a quartile, the first thing you're going to do is arrange your data from least to greatest. Okay, so number 2, the second thing you want to do is find the median. The median is your Q2, okay? Then you're going to find Q1, which is going to be the median of the bottom half. And then Q3 is the median of the top half. Let me try to explain it better with a picture. Okay, let's say you have data. So here's all my data. The very first thing is you're going to find the median of that data. That's Q2. Okay, so then you have this bottom half over here. You're going to find the median of that. That's going to be your Q1. Then here's the top half over here. I'm going to find the median of that. That's going to be my Q3. So now I have quartiles because I broke it up into 4 pieces. Okay, and we know how to find median. We've already learned that. Now, what is so amazing is that your TI-8384 calculator finds quartiles for you. So let's say that you have this data. If you don't have a TI-8384 calculator, you're going to have to put this in order from least to greatest, find the median of the first half, find the median. So if you have a TI-8384 calculator, the very first thing you want to do is go put this in your list. So I've already explained how to do that. You're going to go to Stats, hit enter for edit, and you're going to put this all in your list 1. So you're going to put all of the values in list 1. Okay, once it's all in there, then you're going to hit stat again, go to calc, hit enter for your 1-bar test twice so that the first time you hit it, 1-bar stats shows up on your home screen, and then you hit it again and all of the data appears. If you scroll down, you'll actually see Q1. And so Q1 is 2.6. And then if you keep scrolling down, you have median. Remember, median is your Q2. So that's 3.805. And then if you scroll down one more time, you get your Q3, which is 4.94. Now, once you have that, you can find your inner quartile range. Let me get some space here. Okay, your inner quartile range is going to be Q3 minus Q1. Because you know range is the highest value minus the lowest value, but with inner quartile range, you're going to take Q3 and subtract Q1. Okay, so in this case, I would take 4.94 and subtract 2.6. And when I did that, I got 2.34. So 2.34 would be my inner quartile range. Okay, the last thing I want to discuss, let me clear this off, is how to find outliers. Checking for outliers. Now, what's an outlier? An outlier is a piece of data that doesn't fit with your other data. For example, if my last test was someone made an A, B, B, A, F. Okay, so everyone passed with A's and B's except for one person failed with an F. Wouldn't that F mess up my average? Wouldn't it pull my average down? Does that make sense? Wouldn't that one piece of information that doesn't fit with the rest mess up my data? Okay, and because of that, we have to be able to identify outliers. So the very first thing you want to do when you're trying to identify, you're checking for outliers, is you can use your quartiles to do it. The first thing you want to do is find your first and third quartile. So you're going to find oh, let me erase that, sorry. You want to find Q1 and Q3, okay? The second thing you want to do is to find the inner quartile range, which I just showed you how to do. You take Q3, subtract Q1. The third thing you want to do is to determine your fences. Now, your fences are like cutoff points. If your points are not between here and here, then those are outliers, okay? So to get the lower fence, you take Q1, subtract 1.5 times your inner quartile range. To get your upper fence, okay, you get your Q3 and you add 1.5 of the inner quartile range. Okay? So, taking our data that we just had, let's find the lower fence. Okay? The lower fence would be your Q1, and our Q1 was 2.6 minus 1.5 of the inner quartile range, which we got was 2.34. And I get negative 0.91 as my lower fence. To get my upper fence, I'm going to take Q3, which was 4.94, and I'm going to add 1.5 times 2.34. And you get 8.45. 8.45. Okay, so I have negative 0.91 as my lower fence, 8.45 is my upper fence. Now go look at the data again. Hopefully you wrote that all down, or if you can rewind it and look at the data again. Look at all of the values. Are there any outliers? And the answer is no, there are no outliers because all of the values that we have are in between the lower and upper fences. If there were numbers that were below negative 0.91 or above 8.45, those are the ones that would be your outliers. Okay? All right, I hope you learned a lot. If you have any questions, feel free to ask.